So if a quadrilateral has two pairs of parallel sides, then it is a parallelogram. So a quadrilateral, that's a four-sided figure, and if it has two pairs of parallel sides, so here and here, that would be parallel, and then here and here would also be parallel. That would be called a parallelogram. So this side is parallel to that one, and this side here is parallel to this side. That would be a parallelogram. You can also classify a quadrilateral, a four-sided figure, as a parallelogram by showing that both pairs of opposite sides are congruent. So if you show that you have a quadrilateral that has the opposite sides congruent, so this side is congruent to that one, and this side is congruent to this side, then it is saying that it can also be a parallelogram. So if this was like 8, and this was 8, and this was 4, and that was 4, right? That would also be a parallelogram. You can use these and other properties of geometric figures to determine the coordinates of a missing vertex. So that's going to lead us to example 2, talking about missing vertices. So example 2 says find the coordinates of a missing vertex. So we have triangle ABC, okay, has a right angle at B, and AB is equal to 6. Find one possible coordinates for A. Okay, so we have C here, we have B here, and it's a right triangle, and it says there's a right angle at B. So here, for a right angle to be at B, we'd have to go this way, right? And it says, we don't have A, but it says AB, so A would be over here, is 6. So it would be here, 1, 2, 3, 4, 5, 6. Let me double check that. 1, 2, 3, 4, 5, 6. Yeah, that would be A. And if we drew it, there would be our right triangle. So we have our right angle here, and AB, I'll make B right here. AB is 6, and A is, what are the coordinates of A? 2, and then up 3. So the coordinates of A are 2, 3. That's one possibility. All right. Okay, let's go ahead and look at this one. This says a quadrilateral ABCD is a parallelogram. We're supposed to find the coordinates of D. Now, parallel lines, right? So we know A, B, C, D is most likely going to be down here, but we need two sets of parallel sides, right? So B, this, whatever this line is, this line has to be parallel to it. So for it to be parallel, they're going to have the same slope. So if I can determine what the slope is from B to C, that would have to be the same slope from A to D. So slope, remember, is rise over run. So if I go down 1, 2, and then go over 1, 2, remember slope. Slope equals rise over run. So the slope of BC, is equal to down 1, 2 over 1, 2. Now, for this to be a parallelogram, the slope of AD has to be the same. Parallel lines have the same slope. So we would go down from here, down 2, 1, 2, and then over 2, 1, 2. And that would give us D right here. And that would give us our parallelogram. Now we can check, right? Because we used the slope of this line and the slope of this line, so we know that these two lines are parallel. But let's go ahead and check the slopes of these lines. Okay, so the slope from here would be up 1, 2, 3 over 1. And for here would be up 1, 2, 3 over 1. So they are parallel as well. So there we have it. So what are the coordinates here? This would be D is 2, 2, -1. Okay, so the coordinates of D are 2, -1 for that parallelogram. Perfect. Okay, let's go ahead and look at the next example. All right. Here. And I want you to go ahead and try this one on your own. So this says, and make sure you write in these letters, B and C. Triangle ABC has a right angle at B and AB equals 4. Find one possible coordinates for B. So I want you to go ahead and try this one on your own. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work it out. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did. So this says it has a right angle at B. You know what? I think I messed up. Did I mess up? Maybe I didn't. How am I going to make that a right angle? That's going to be, I think I messed up on the letters. Maybe I didn't. AB, a right angle at B. Oh, man. Oh, wait. No. These didn't have. I'm going to take this away. I'm sorry. Erase that. I think what I'm going to do is have, in order to have, because I can't have a right triangle anyway. So in order, I'm sorry about that. In order to get a right angle, I think I need to go here and go here. And then that's how I get my right angle of B. And then AB has to be 4. So which one of these side lengths are 4? 1, 2, 3, 4. Okay, so I'm going to call this A. And this is going to be C. And so these would be my coordinates for B. That would be 2, -2. All right, so my coordinates for B are 2, -2. So sorry about that labeling. I messed up on the labeling. Okay. All right, let's look at this one. Quadrilateral Pqrs is a square. Find the coordinates of S. Okay, so we have P, Q, and R. We got to find S, and it's a square. So that means that all the side lengths are the same. So we have 1, 2, 3, 1, 2, 3, and it's going to be 1, 2, 3. It's going to be right here. Okay. So this is going to be S. And what are the coordinates? 1, 4. All right, that's it. Okay, let's look at this last example that is dealing with a quadrilateral. So it says quadrilateral ABCD is a rectangle. Find the coordinates of D. So we have ABC. We know we need a rectangle, so they all have to be, all the angles have to be 90 degrees. So if we want that, this has to come down here. This has to come over. Yeah, and it's going to come over here. For a rectangle, the opposite side lengths have to be the same. And this is where our rectangle would be. This would be D. And what is that? 1, 2, 3, 4, 5, 6. 6 down, 1, 2, 3, -3. And that's what D would be. All right, that's it for this. That's it for this example. I'll see you in a little bit for the next example.